The distributive property is used to multiply over addition. So in a problem like this, you have a multiplication problem here. This implies multiplying even though there's no sign here. But you've also got this addition problem within the brackets. So the distributive property says you need to distribute this multiplication over the addition. So first of all, you will multiply 2 times x. And notice how I put down the symbol for adding. Now I do 2 times 3, and I have 6. Now I'm also going to I'm going to model this with the integer tiles so you get an idea of what I'm doing here. The integer tiles that I have here now, or the algebra tiles I have now, represent x plus 3, which is what I have in the brackets here. And the 2 in front implies that there are 2 groups of x plus 3. And here I now have 2 groups of x plus 3. X plus 3 here and x plus 3 here. So my total that I've got is 2x plus 6. So if you think about the algebra tiles and how they can model different expressions, it will help you to understand the distributive property a little bit. Now let's try one with subtraction. First we'll try the model to see what it looks like when we model it with the algebra tiles. So we're going to model this value in here, or this part of the expression in here. We'll model x minus 3. So these algebra tiles represent what's in the brackets, x minus 3, x and negative 3. Now let's do 2 times that. Now I've modeled 2 groups of x minus 3, or 2 times x minus 3. So what am I left with? Let's just take a look at what we've got. The algebra tiles tell us we've got 2x and we've got negative 6, or minus 6. So if we take a look back at our expression here, that would be the same as multiplying the 2 times the x and the 2 times the negative 3. Our result is 2x minus 6. Now we'll take a look at distributing a negative number over addition. Now you'll remember that when we start by multiplying a negative number, that means we have to take something out. And we have to take out 3 groups of x plus 1. Well, we don't have any groups of x plus 1, so let's start putting some in. So the only thing we can do here is add some 0 pairs. So that's exactly what I've done. I've added some 0 pairs so that I can take out 3 groups of x plus 1. So by adding the 0 pairs, I haven't changed the value of what I'm doing. But because we have this negative here, it means we're starting by taking something away. So we add the 0 pairs so we have something to take away. Now I'm going to take away 3 groups of x plus 1. So you can see I'm left with negative 3x minus 3. I'll just write that down. Minus 3x minus 3, or negative 3x minus 3. And let's see what happens when we do it this way. So we do negative 3 times x, which gives us negative 3x, and then we do the negative 3 times the plus 1, and we get negative 3. So our answer is the same either way. So if you do get confused with the distributive principle, just try a few of the questions using the algebra tiles and try to model what you know. We're just going to take a look at one more example. An example here is negative x minus 1. Now first I'm going to model it for you, and again, because we're starting with a negative, it means we have to take away, and because there is no number here or anything to tell us what we're multiplying by, we infer that it's a negative 1. So this is just like saying negative 1 times x minus 1. So what we need to do is we need to take away one group of x minus 1. So let's get our group of x minus 1. And remembering that we can add some 0 pairs. And so here I've added 0 pairs. I've kept my value at 0 still. But now I want to take away one group of x minus 1. So let's start by taking away our x, and then let's take away a negative 1. And what we're left with is negative x plus 1. So that's what that would be equal to. So let me just write that down. Negative x plus 1. And if I look at it the other way, I've got negative 1 times x, which is negative x. And I've got negative 1 times negative 1, which is a positive 1. So whichever way I do it, I come up with the same result, whether I'm just using my distributing principle here or if I'm modeling it with the algebra tiles.